Hey guys, today we're going to be talking about the theory of how we set up a hypothesis testing and how we interpret the results. We won't get into how we actually do the testing until the next video. But for now, we're going to talk about how we set them up and how we deal with our answers. So, when we do the process, we're going to, at the end of the process, we'll get a number, and we're going to call that our p-value. Right? And it's going to tell us how likely it is that our null hypothesis is true based on some claim we made. What is the probability that we would get the results that we got if the null hypothesis is true? Smaller p-values are evidence against the null hypothesis because they say that the observed result is very unlikely to have occurred if the null hypothesis is true. Large p-values fail to give convincing evidence because they say that the observed result is likely to occur if the null hypothesis is true. Remember, we got into this last class and we talked about, we made an assumption and we looked at the sampling distribution and said how likely was our result if we accept the truth that was in the null hypothesis. And if we get a very low probability, that's a low p-value. So when we get done, we're going to make a decision. And we're going to either reject the null hypothesis or fail to reject the null hypothesis. And that's going to be based off that p-value. And so if our sample result is too unlikely to have happened by chance, that if with the assumption that H naught is true, then we'll reject the H naught. We'll say, hey, the null hypothesis must be false because it's so unlikely that we would get this result if the null hypothesis was true. If we don't get a number that's low for our p-value, then we're going to say, hey, we're going to fail to reject the null hypothesis. It could be true. It could not be true. We're not sure. The big thing here, and this is a big deal, is that if you fail to reject, it does not mean the null hypothesis is true. You never say the null hypothesis is true. We just say we reject it or we fail to reject it. And when you do chi-square in biology, you can get in this fight as well. If you say the null hypothesis is true, you're going to lose points immediately on the AP exam. Can't do that. We either reject it or we fail to reject it. In a nutshell, you're going to do one of two things. You're going to have two choices. You get a small p-value and you'll reject the null hypothesis and conclude that the alternative hypothesis is true. You're always going to do that in context. You're going to repeat the question back to them. And we'll practice this in class. Or if the p-value is large, you're going to fail to reject the null hypothesis. Then you're going to say we lack evidence. We do not have sufficient evidence to say blank. The key is this language of I fail to reject. We fail to reject the null hypothesis. We do not accept it. We just fail to reject it. Another way to think about this is our old standby. If the p-value is low, we reject the hoe. Now, there's no rule for how low a p-value should be in order to reject the null hypothesis. It's kind of a judgment call, and it depends on the circumstances. In social sciences, a lot of times we'll have a higher p-value because we're just trying to show that something's happening. And we'll talk about this later. On the other hand, sometimes in a medical experiment, you'll want a very, very low p-value because there could be, it's like, does this drug work? And you're going to test it. Well, if the drug has horrific side effects, we want to make 100% sure that it works. The key thing here is we're going to set our level, our threshold for whether we will reject or fail to reject, and we're going to call that alpha. And the key thing is alpha must be set before you do that. So you would set, like if you were doing this problem, in real life you would set alpha before you collected any data. On an AP exam, the data was collected for you, but you would set alpha before you perform any significance testing. So you would state your null hypothesis, and you would state your parameters, and you would state your alpha level. Oh, sorry, this should be if. In the absence of instructions, our default is alpha equals 0.05, which should seem fairly familiar to you guys at this point. So basically, in a nutshell, we would set an alpha of 0.05. So if we do the significance testing and we get a p-value of 0.03625, then we would reject the null hypothesis and conclude that we have, and this is a key phrase coming up, statistically significant evidence that, and then we would put in the context of the alternative hypothesis. And that's the language you're going to use. We reject the null hypothesis and conclude that, and we actually wouldn't even say conclude, we would say we reject the null hypothesis. We have, I already have the word there. We have statistically significant evidence that blank, whatever our null hypothesis is. Whatever our alternative hypothesis is. And this is the language that you're going to use in your last sentence in your conclusion, part 4 of your AP exam question. So this is really it. If your p-value is small, less than your stated alpha, you reject the null hypothesis and conclude the alternative. If your p-value is high, then you're going to fail to reject, and you're going to say we do not have sufficient evidence to conclude anything. Remember, we never accept the null hypothesis. All right. Now, the thing is, we're saying the p-value is the probability that we would get our result if the null hypothesis is true. So if we do a test and we get a p-value of, let's say, 0.0375 was the example I used a few seconds ago. That means there's a 3.75% chance that I would get that result if the null hypothesis is true. That means it's a very, very unlikely event, but it's not an impossible event. And so what we get into is we get into trouble because there's a chance that we could be wrong. There's a 3% chance that the null hypothesis was true and we were just very unlucky. And so there's errors that we can make. And these errors, it's important to make the distinction as we talk about these two types of errors, which are the type 1 and the type 2 errors. These are not mistakes we made in designing the experiment. These are not mistakes we made in our calculations. They are errors due to the inherent probabilities and uncertainty and randomness. It's basically saying, and this is where statistics gets ugly, is that we can do everything right and still get the wrong result because of bad luck. And so there's two types of error. There's the type 1 error, where we reject the null hypothesis when it's true, And there's the type 2 error where we can fail to reject a null hypothesis even though it was false. And this is summed up in a chart here. So here is what the truth. We don't know. Oh, sorry, I don't know what happened there. Here's the truth. And the trouble is we don't ever really know the truth. They're going to ask you about this on the AP exam, but in real life you would never know the truth. And then this is our conclusion. And so there's a possibility that H naught is true. Well, if H naught is true, the ideal thing is that we fail to reject, and then we would say we do not have sufficient evidence. Cool, we got that one right. Or it could be that the null hypothesis is false, so we reject it, and we make the conclusion that HA is true, which would be correct. But there is a chance that the H naught is true, and we reject it. And the chance of that happening is actually our alpha level. If we set our alpha level at 0.05, then there is a 5% chance that we can make what's known as a type 1 error. There's also the chance that the null hypothesis is false, but we fail to reject it. We do not have statistically significant evidence that the null hypothesis is false, and so we fail to reject. And this is what is the chance of that happening is something known as beta, and we'll get into this next video when we talk about the power of a test. Because really, we do not want this to happen, and we do not want this to happen, and it's a question of how we balance those two. As far as how do you remember type 1 and type 2 is, right here our mistake was that we fail to reject, which leads to a type 2 error. And we're going to go through in class, and one of the things you're going to have to be able to do is they're going to give you a set of hypotheses and say, okay, what is the consequence of a type 1 error and what is the consequence of a type 2 error? And so you're going to have to look at, figure out what the mistake was and see what would happen. Remember, we can assess the performance of a significance test by looking at the probabilities of the two types of errors. That's because statistical inference is based on asking, what would happen if I did this many times? And that's the whole idea behind the sampling distribution. So alpha is the probability of a type 1 error. The lower the alpha level, the less likely we will be to make a mistake, but the harder it is to actually prove what we wanted to prove. Because we do a significance test not on a whim, but because we're trying to prove something. We did a study, someone made a claim and we collected data. We're trying to prove something. If we fail to prove it, then we wasted our time. Or hopefully we learned something. So that's it, and we're going to get into in class, and we're going to be doing, okay, you get this p-value, what do you do, and what are the possible errors? So I will see you next class. If you have any questions, bring them to class. Talk to you guys next class.